And now we're ready for the next talk. We've got one Brian Cardarella, who's CEO of a little consultancy you might have heard of called Dockyard. So give it up for Brian, everybody.
Everybody, thank you for having me. I was a late addition, but I wanted to come here and start talking about and showing LiveView Native, which I've been talking about for 3 years. So a little bit of history. I'm not going to assume that everyone knows what it is. So LiveView Native is a project that started at Dockyard a little bit over 3 years ago, and the idea was, can we actually build native applications using the LiveView protocol? And so to be clear, these are not web views. This is not like a JS interop or JS bridge that's occurring. It actually uses the LiveView diffing and all of the event system, everything that LiveView does, but we built custom clients in. Right now, what I'm going to be showing is, thank you, the Swift UI client. We have a Jetpack client that's very close to being ready for use, probably in about like 2 or 3 months. And this dramatically opens up the door on like what Elixir and Phoenix can potentially be applied to. So up until now, Phoenix has been a web framework, and it'll continue being a great web framework. But the way I've been describing LiveView Native is that this allows us to build LiveView applications for anything with a screen. We are actually we're establishing a WebSocket connection. We have to effectively reproduce a browser in the client, because that's what LiveView ultimately wants. Sorry, I keep turning my head away to look at this screen. I'll just look at this one instead, or my screen right here. So today I'm going to be showing off a few different applications rather than going through how to do it. We are approaching release candidate 2 of 0.3. 0.3 is finally the version that I'm telling people you can actually go out and build actual applications with. You can deploy it to the App Store, et cetera, et cetera. We're expecting 0.3 to probably be out maybe in just a few weeks. It's down to like documentation, getting the tutorial complete. Brooklyn Myers, who put together the Dockyard Academy tutorials through LiveBook, for those of you that may have used that, he's been building out a really great LiveBook tutorial for LiveView Native as well. So you'll be able to actually build out your LiveView Native applications in the LiveBook and run the simulator right next to it. We actually have like a little QR code that you'll be able to take a picture of in the LiveBook. You download an application from the App Store. You won't have to set up Xcode, and using the QR code, it will connect to your LiveBook automatically, so you can actually just make your LiveView Native application changes in the LiveBook, and it will all be pretty seamless. So this will all be coming out in the next few weeks. But some of the progress we've made just recently, we've been waiting on upstream changes in Rust itself. So we use Rust for our core library, which manages the network connection, manages the like what MorphDOM, the behavior that MorphDOM supplies to LiveView. It does all the document handling. And we did that so that we can actually not have to reproduce that on every single implementation. So we don't want to have to reproduce Phoenix channels. We don't have to reproduce MorphDOM and all the LiveView event handling for SwiftUI, and then have to reproduce it for Jetpack, and then have to reproduce it for WinUI 3. So we built it once in Rust, and now we're actually starting to consume it in the clients. So what this is going to be showing today is a little bit of a change of an application that I showed for ElixirConf EU, and then a demonstration of an application I built at home. However, what I will say is that I actually had this all working in production-built applications, and then this morning, sorry fly.io, but I could not deploy to fly.io. It was timing out for me, and so for the past 30 minutes, I've been rapidly changing everything over to localhost. I was going to show on my Vision Pro and like connecting it for real, but we're going to have to do everything through simulators, and I was pre-compiling everything, so hopefully we won't have to sit through too many compilation times on Xcode itself. Demo versus real. I know, exactly. Although I blame Fly for this one. Okay, so yeah, I'll just, hey, pre-compilation worked. Okay. This is a pretty basic application. It's going to be showing a few of the functionality in libraries that we've wrapped for LiveView native. The first here is, actually, can I put this on top? There we go. All right, so the application that we have here, you can see right in Home Live here, where if anyone here is familiar with SwiftUI in terms of the views and the modifiers, this is going to look somewhat familiar, but like the markup version of it. And that's how we have gone down the road of trying to represent these UI frameworks so that they work with LiveView itself. So in the upstream UI framework, VStack is a view, text is a view, group is a view, HStack is a view. These are components that we've written that emit out LiveView native. Well, could you bump the font a little? Oh, sorry. All right. These are components that we've written that are intended to be identical to the core components that you get automatically with Phoenix. The idea there is that while the markup of the underlying views for the UI frameworks are going to be a new thing to have to absorb, if we can abstract these away with common API for as many of the components as possible, it's going to speed up development. And on top of that, our styling system, I mean, this looks like inline styles, and that's effectively what it is. We're actually going to be moving this syntax over to a style attribute and reserving the class attribute for doing what you normally do with CSS, assigning a class name and then having to look up the style rule. But this is, again, a representation of the modifier system that exists in SwiftUI. So I can actually go in here and let's say, hello today. GigCityElixir. And it does live reload for you automatically. For those of you that may have done some native application development, you're probably saying, oh, wow, that's way faster than having to stop the simulator, recompile everything, and then run it again. And it is significantly faster. And it's much more reliable than Xcode's preview system as well. So we'll go in here, we'll check out forms. And these are just simple form controls. So if I go into the form template, we'll see these all look familiar. These are all the exact same API as the regular core components that we're getting. Another change that's going to be coming is, sometimes when we're developing this, it's hard to see the forest of the trees and trying to align it with what LiveView is doing. We got a decent ways through, we're calling this live form because SwiftUI doesn't have like a form concept in terms of being able to serialize its children and capture, submit actions within a form. But LiveView itself requires things like change events to actually be wrapped in a form itself. So while this is form, this is really just like, this form here does nothing. This is just presentation. It's going to look bad coming out of here. And this is how SwiftUI ends up styling things. It's just really for looks. It has no functionality. But we have a library called LiveForm that provides all of the same behavior that you expect from like the form component or the simple form component. Next, we'll go back and we'll check out some videos. So these are some open source videos. Big Buck Bunny is by the Blender team. And, oh, you can't hear it because I have to bring the microphone down. But we can go through. Oh, there we go. And these are all just like lazy VStacks, which allows for like rapid rendering of lists. There we go. All right, stop. Next we have map. So BVI, because I like the BVI, and I'll say, there we go. So this is through the MapKit SwiftUI library, and we've wrapped that as well. I forget what percentage of MapKit we currently have wrapped, but we can do things like markers and positioning, being able to, I think we can follow as well, and there are actually change events that come back too. So if I were to go into here, And I think, okay, all right, so I'm gonna do something that you should never do during a presentation. I'm gonna try something I haven't prepared for. So we're just gonna see what happens. Change equals map update. Okay, I think that should work. Let's see now. It's probably gonna crash the server because I don't have a handler. Yeah, so it, let's see what it sends back. Let me just move this stuff out of the way. Go away, simulator. So, where is it? Yeah, position. Oh, the position's empty. Oh, okay, I probably have to provide that as a value for the change event itself. But we can respond to them. We can listen for these events. And finally, the worst looking one, because I'm not a designer, if you can't tell based upon my application design here, is a chart library. And I should have updated this after ElixirConf EU. What I was intending to do was actually having like a Spark chart, kind of like an uptime or like a stock chart. But yeah, my design skills are lacking. Okay, so let's try to compile this for a different platform now. So if I come out here and I'm gonna say, this is gonna look really interesting because like all the Apple ecosystem devices look pretty good with SwiftUI, except for Mac OS. But we're gonna see what it looks like. Oh, this is probably complaining about. Just want to rebuild. Awesome. God damn it, Xcode. All right, let's stop the simulator. Rebuild. Okay, so while that's rebuilding, because this is going to take like 45 minutes to rebuild. Not really, it's going to take like 2 or 3 minutes. What I'm going to show is an actual video of a tvOS application that I built at home. So kind of the thing that got LiveView Native started as a project, there were 2 projects within Dockyard that gave me some incentive to do this. One of them was my wife plays piano. We have a baby grand piano at home. It's a Yamaha disc lavalier, and this is a self-playing piano. And it works by these videos that Yamaha put out, like the left audio track is the actual audio track, and the right audio track is a static track that the piano controller can listen to and actually play the piano alongside with it. It's pretty cool. So you can do stuff like, oh, there's my Mac application. So yeah, it compiles out for Mac, but it looks bad. I would have to go in and actually go and make this look good for Mac. So let's go and, I'm not gonna make it look good because I don't have design skills. What I will do is show that I can actually compile for specific targets as well. So I think let me just move this. Can this go down? Okay, all right. So your applications, you're gonna want to, is that picking up? Sorry, I can't hear myself. Your applications, you probably want to support multiple devices from the same server. And in order to do that, we have exposed what we consider to be the target. So the target would be like iOS or Vision OS or Mac OS. And the default here, if you look at the template naming, maplive swiftui.neeks. Neeks is our own template format because Heeks really adheres to the HTML specification, and we're not HTML, so we had to have our own template format. And then the actual inbound request format being SwiftUI, we treat the clients as their own format. So Jetpack will be a Jetpack format. WinUI3 will be a WinUI3 format. And then it comes with this entire interface object along with the initial connection. And that's going to include information on the orientation of the device. It's going to include, is it in night mode or day mode, version information, that sort of stuff. And then in addition to that, what operating system and what device is actually making the request. So in this case, we have a MacBook, Mac OS. So I'll just do plus Mac OS. Oh, actually, make a new file. And I'll call it Home Live. .swift UI plus Mac OS. Okay. So Yeah, so it's blank now because there's nothing there. So I'll just say, let's text, I'll say, I'm speaking at GigCityElixir. Really, really tiny. And then I'll add a class, let's say font, title, bold. So if I were now to disconnect with this, and I hopefully won't make everyone suffer through another recompilation, but let's just see how quickly this rebuilds. All right, it's doing a full rebuild. This is my fear. That's why I wanted to have everything on fly.io. Okay, so while that's, I'll go back to my previous story now while this is rebuilding. Okay, so the Disclavier piano, self-playing, it takes that audio track, and so there's things like you can have like a Billy Joel concert playing, right? And the piano that Billy Joel is playing on, it will record in real time the piano, the keys in which he's hitting, the pressure, the pedals being pressed, et cetera, so it plays back like perfectly. The unfortunate part is that you know, you have this really nice, beautiful, grand piano, this really cool experience of like the piano playing for real. But then the application they use to actually stream in these videos is this dinky little iPad app. And I have like a decent sized TV at home. And I've always wanted a TV, like a tvOS version of this application. I'm gonna finish the story first before I go back. So anyway, at the time, a few years ago, I looked into it. I started to play with tvOS development, and there's this way to build TV applications called TVML, television markup language, for tvOS, and it's pretty limited, but it got part of the job done. But while I was building, I was like, oh, this is not too far away from potentially being a LiveView thing. There was another project that also got me interested in pursuing LiveView Native as a thing, but all that to say that I spent 3 years and probably close to $1 million of development for a framework just to build a TV application for my wife. So we'll show that in a minute. All right, so the point here that kind of got lost because of the recompilation step was that it reconnected to the same server, but this time it's not serving up the Mac OS template, right? It's serving up the general Swift UI template. So if I were to go in now and add, I'm not in my editor, add a iOS one. Now that will be blank again. So you can start targeting like per device and having your server actually be able to be a LiveView native server for all your devices and all the devices within a platform family, and then all the devices, all the platforms, hopefully, once we get the other platform clients out. Okay, so let's go to that video. All right, so the way I was gonna try to do this is, it is gonna play some audio. I'm gonna try to put my microphone next to my speakers so that it can pick it up. The only thing is I don't know where the speakers are on the air. They like in between the screen. All right, we'll see how this goes. All right, let me minimize this. Welcome to my home. All right, so I scraped all the data off of the Yamaha website, sorry, Yamaha, and then their MV4s, like all the videos are categorized. And so this is I built this application in about 3 hours of time, mostly because, again, I'm not great at design, to get looking halfway decent. But we have like category filtering, to scroll through everything. And then I think so I go to, I guess this is Elsa. Is it gonna play? Okay, so it takes a second because it's gotta show me like the Yamaha splash screen, Disclavier TV. So the way that this is hooked up is there's an AirPlay receiver on the piano, and it has an audio jack going in. So I have the tvOS application running on my TV, and I just AirPlay to the receiver on the piano, and it picks up all the keys and plays alongside of it in runtime. so one last thing I want to show today is it running on Vision Pro as well. So we're going to try that. There's the Vision Pro simulator. Part of the kind of real challenge with building out this these clients has been, we spent a lot of time just debating what LiveView native even means for native applications. And this kind of started as like a hybrid model. Oh yeah, sorry. Listening to my keyboard. Whoa. This started as a hybrid model where it's like, okay, there's state that exists on native and it wants to manage its own state. LiveView itself wants to manage its own state. How do we kind of rectify that? And we went down a lot of different paths. And at Dockyard, I tend to burn through a lot of money on like dead-end R&D projects, Lumen. But I wanted to vet out the direction as much as possible. And where we eventually ended up was a position where as I said earlier, we've effectively had to reproduce the browser as a native client. We try to keep as much state within the server as possible, but LiveView native is actually built in such a way where it's a view for that upstream, for that UI framework. So you can have a hybrid application. You can have a existing native application that your team has and add in LiveView as another view. So like if we were to go into, I'll come back to that in a second, inside here. So we can see here that LiveView is just another view within SwiftUI's view tree. We could add our own SwiftUI stuff right in here, and it should be just fine, but I'm not going to force another recompilation upon everybody. Okay, so down here. All right, this would have been a lot cooler if I had my headset working, but because my laptop ended up on a different subnet than my Vision Pro, it wasn't communicating over localhost, even with loopback turned off. But see if I can zoom this in somewhat. I think I can do, yeah, I should be able to do that. Okay. Yeah, so we have all the same functionality, just not designed for the Vision Pro just yet. And to be clear, this is not a Vision Pro compiled application for iPad running. This is not an iPad application compiled for Vision Pro. This is actually a Vision Pro application. What we are starting to explore now is wrapping like the ecosystem of Apple libraries. And one of the very first things I want to start wrapping is RealityKit, because I'm pretty sure that we actually can build AR and VR applications with LiveView native. Like there's kind of a limit to how far we can go with it. But RealityKit and all the immersion framework, the immersive framework within Apple, these are all just SwiftUI views. And so we can bring them in, we can set up scenes. Loading in meshes are off of URLs, and we should be able to bring those in remotely, provided they're not too big and the experience doesn't get hurt by that. We can also load stuff into the asset catalog in Xcode and reference it within our LiveView native application. So there's multiple ways we can actually make this work and have it work well. So my goal is to have something like a demo like an AR demo with LiveView native for ElixirConf in August. So come to ElixirConf if you want to see that. I'll turn this off. Finally, I will show Apple Watch. So Apple Watch is a bit of a different beast. Because it has to pair, Apple Watch applications have to pair to like an iPhone to, I think, do most of what they don't have the power on device to do. We have to compile this as a separate project. So when we generate your LiveView native project, it'll create a native directory, and then the framework will be a director into that. So in this case, it's under native SwiftUI, like in there. And we have to create the multi-platform target project. So that includes everything. So if I go here, that includes all these devices here. And then, unfortunately, Apple Watch has to be separate. So if I recompile this, So I had that as a separate Xcode project already compiled, because compiling for Apple Watch is actually the slowest of all of them for some reason. And I'm in the application now. So here is the same thing, but now represented, squished down for the Apple Watch format. Some of these controls don't work on Apple Watch. Like there's just certain views that are supported on one platform versus another, and you have to be aware of that when you're designing for the specific platform. But here's the name of the view is called picker in SwiftUI, the equivalent of like a select in HTML. I'll set that, and that's set to red there. This is a step, which is, these are just effectively buttons that can step up through a value. These are, there's a text field. Oh, great. All right. Whatever that does. And a toggle button is the equivalent of a checkbox. And then this is a range slider, but it doesn't like work that well on Watch. Like there isn't much space, but I don't know how to get it to look nice. On the other platforms, you got the little button you can slide back and forth, but that apparently doesn't happen on watchOS. I am curious though if it'll play the videos. Let's find out. No, it won't play the videos. Oh, that might be because I don't have AVKit. Yeah, I don't have AVKit. All right, I'll force it through a recompilation. It might play the videos. I could try that later. Okay, so that is LiveView native. As I said, we are getting very, very close to the point where I can share it and everyone else can start building with it. I look at this project as a, not just a cool project that expands our ability to start building other applications for our clients, but in addition to that, like Elixir itself, I want Elixir to win as a language, as an ecosystem. And the more ways we can actually keep doing things in Elixir, as opposed to saying, okay, now we have to have a React Native team, we have to like go out and work with a SwiftUI consultancy. We want to make sure that you all, as Elixir developers, can actually apply your skills to as much out there as possible. And LiveView native, like up until today, LiveView is a web framework, but after today, or very soon after 0.3 is released, you're going to be able to build for effectively any device out there. We want to start exploring, like when we share the core library, the rest of the library we wrote, we'll start to build out tutorials on how you can build your own clients. Something I think that might be cool is like Godot Game Engine, for example. They have a basic UI framework, and doing like multiplayer scoreboards with LiveView native would be pretty rudimentary with that. I'd like to build out a Scenic client. I do a decent amount of Scenic development on my own, and getting that to actually run LiveView native applications would be pretty cool. So anything with a screen is really our goal, ultimately. But Dockyard itself will probably limit ourselves to SwiftUI, Jetpack, and then probably WinUI3. I'm not looking forward to doing Windows development, but it's necessary. So that's it. Thank you very much.